Welcome to this week's episode of Tell Us Something We Don't Know, a serious chat with a comedian. My guest today is really hard to define. What first piqued my interest with my next guest was the thought process he took when tackling everyday problems, which led him to become an inventor and a consultant to big businesses around the world, helping them solve some of their own problems. During the week, he works in his own business called Quantum Bicycles in Perth, but we are not here today to talk about bikes. Today, we get to hear about what Aldo Contarino thinks about what's currently happening in the world, what he has invented himself, and he also gives us some fascinating insights into how history has helped shape technology today. Welcome, Aldo.
Hi, Joe. How are you today?
I'm good, mate. So how does a high school dropout end up becoming a problem solver and inventor?
It's really funny. I started very, very early on in life where I was actually building a little billy cart. And
How old were you?
Look, I would have been in grade one, so only 5 years old, building a little billy cart. And my brother comes out. I looked at the steering and how the steering was working on my father's car, and everyone had these little ropes, tied to a plank of wood. So I decided to actually put a steering wheel in and, put a rope around one section. And when you turn the wheel one way, it went the other way. And then I worked out I could flick it the opposite way. So really it was just like a rack and pinion, but just using ropes. But it was interesting. My brother comes in and goes, "Wow, who built that?" And it's like, "I did." He says, "You worked that out? That's brilliant." He just loses it.
Was he an older brother or a younger brother?
It was my older brother.
In
fact, he was my oldest brother, Mario. And anyway, he saw that, and it was like, for me, it was just like, wow, I'm good at this, so I'll just keep going.
Right.
I just kept fixing things, and then my dad said to me that no one actually did things good in the world, so the job was pretty well set out for me. I just had to keep making things good.
So are you university qualified, or you just dropped out of school and started doing other things?
It's really funny. I actually I dropped out of school early, and in the bike industry there was some frame builders. There was quite a lot of frame builders when I was young, and they one particular guy that I actually remember was bronzing up some steel, and he was mixing the flux with olive oil, and I'm thinking, this is really weird. This guy's mixing the flux with olive oil. And I said, why do you do that? And he goes, "Oh, if you don't do that, Sonny, it just doesn't bloody stick." And chemistry 101 just smacked me in the head from school, like, the hydrogen burning off and leaving the carbon behind and cleaning up the steel. So I pretty much saw the history lesson and the chemistry lesson from what I'd actually seen at school. And I was sucked in. I was just sucked into the industry. It was like, wow, this is just straight physics and straight chemistry. I just loved it.
And so from there, how did you use that to start your business? What did you do in the bike business that no one else has done? Or what have you bettered in that business?
So first of all, I actually started, overhauling gearboxes and working on bits and pieces in the bike industry. And my memory was really good at sort of looking at pictures, and I'd be able to actually see what was going on in the picture. So I would remember the picture. So even today, I can pull up an exploded diagram of a gearbox that I did, 30 years ago, 40 years ago, and I'll still be able to see all the parts in there. So that was one thing, but then understanding how those systems work. So I saw the planetary gearbox, and I saw the suns and the rings and the gears and how the planet cages worked, and it just all made sense. And then I was fortunate enough to have an agent in Japan that I flew over to Japan, and then from Japan it actually flicked over to Taiwan, the industry. So I was going over predominantly to actually visit them for components, to get components in at that early stage for other companies. And then slowly but surely I incorporated that into my own business, and started to actually bring components in and look at manufacturing processes. And I was privileged enough to be able to be taken through different factories
in Taiwan,
and learnt skills from what they were doing in different areas, including going to the US and looking at some of the aviation composite people. And we're talking some fairly high profile, not we're actually talking the highest profiles where I had to sign
Right.
non-disclosure agreements and stuff. But
Yeah.
it was really cool.
Right.
Just
And so how do you go from doing this in your bike shop to becoming an inventor, or to then how did people know to come to you to solve their problems? Right.
Like I said to you, my father always said, no one makes anything properly. So I just looked at all the problems. I mean, if I'm going to design a chair, I'm not going to sit in a chair. I'm going to sit there and I'm going to say, okay, what are the points that I need to hold me up in the chair? You look at the actual problems from a different perspective. And I was actually told at school that if you can't get in one way, you actually set up a nice control and then you actually try and go around it until you find a way in to the problem. So you look at the problem from a different perspective, and not having the fear of failure, because not having the formal education. I mean, if I screw up, hey, I've paid for my own education, haven't I?
Yeah.
So and that's the way I actually look at it, is that you have to be able to make the mistake yourself, be able to repair the mistake and fix all the issues. But having a good understanding of basic principles and in bikes, it's bizarre. The bicycle has got so many interesting variations in design and materials.
Yeah.
You're working with everything from titanium, scandium, aluminium, carbon fiber, resins. You've got all these materials that are available, and then you have to look at how you work with those materials. With titanium, you've got a shield. With carbon, you've got to have no voids in the laminate. So there's all this varying tech that's actually available to you that you have to be able to put together. So then,
so by you doing that, by
by
throwing yourself
resolving
into that over the years, you've learned other things and how to solve other people's problems.
That's dead right. So I mean, you had
Aldo, are you a genius?
No, I actually call myself a Jaffa. A Jaffa is really good because I'm just another flippant observer. We'll use flippant instead of another word. You just look at the problems and you face whatever comes up.
What do you know about geniuses? How do they come about?
Oh, look, I know that a lot of times there's people that are considered geniuses, but realistically, you just look at problems from a different perspective. What someone else sees as genius. I can't understand what people don't see, and they say, wow, you're really good at it. It's like, no, I've just screwed up more times than you, and I've taken it on board not to make the same mistakes.
Yeah, right. Well, tell us some of the things that you've invented. Top three things that you've had a play in inventing. Yeah.
So we were the first ones globally to actually make a Z-shaped bike, which was a Concept Z. Was really to actually make an aerodynamic bike that would have the lowest aerodynamic footprint and stiff sections, and that's where I came across some of the issues with temperature and temperature control, which was a real nightmare. I mean, we spent like $250,000 trying to get a temperature uniform across composites. And then, like I said, a friend of mine who's a material scientist saw what I was doing, said what he'd learned at university was a complete waste of time because I told him my theory on how temperature actually moved, and caught up with one of the companies and a university in Taiwan. So in Australia, I would have had to go to university and I'd have to go through all the, dramas of getting a degree in each area.
Right.
But in Taiwan, I was able to work with PhD professors, and my question to them was, can we actually disprove this theory? And if it can't disprove the theory, then it becomes a law. So they've been trying to crack that and break that for quite some time.
What was this in particular into how composites react to temperatures?
Not just how composites react to temperature, but how you actually transfer temperature. So everyone, when they're at school, is actually taught that temperature flows from hot to cold, and that's all it is. But there was a really weird thing that kept happening every time I machined a component or had to quench it or had to do some hardening of it, and the temperature actually moved completely different to in the bar. So you could feel it. So I didn't have technical measurements from machines monitoring things, but what I had was my fingers knowing damn well that that bar was actually getting red hot as soon as I quenched it.
What does that mean, quenching?
So
I don't know. I've never heard that term
well,
in terms of what you do. So
okay,
tell us
so you
what that means.
get a lump of steel, for instance, and you want to freeze the structure of the steel so that it becomes stronger, right? So
Right.
what you do is they heat it up and they drop it in a bath of oil, or they drop it in different solutions to give you a different hardness.
Right.
So it's a heat treatment process.
Mm-hmm.
But when you're doing that and you're doing it by hand, so if you're only doing a partial temper of something, what was happening was the temperature shoots up the bar. And like, there's all sorts of arguments. Some people would say it was the steam going up the bar, and it's like the bar's not hollow, it's solid. How can steam actually go up a solid bar? So there was all these little weird things that didn't make any sense. So when I posed my theory to one of the professors in Taiwan, they actually found it fascinating. And I actually started treating temperature as light and using different characteristics. So instead of actually using thermodynamics, you actually use you use light trace to actually work out where the heat's actually going to go. And it was a much better way to do it. So,
Okay, we're
words,
going down a rabbit hole here. Let's go back to you inventing.
A little bit hard to explain.
Yeah. Okay. So you invented the Z-shaped bike. Is that what you're saying?
Yeah, we actually worked together to actually just come up with a concept, and then the heat problems were the things that actually someone else saw, and they actually in Taiwan, and then they asked me, can you actually manage the temperature on a PN junction? And I was like, I don't know, but we'll give it a go.
And who uses this bike now? Is it become very popular around the world? What
No,
ended up
it's
happening
not.
with it?
It's funny because we showed it in. It was 2004 that we actually showed it in Vegas, and at the time the Cycling Federation banned it, and they actually said that they wanted cycling to be man against man. I remember laughing and saying to the guy, "Yeah, that's called running. It's always been cycling. Man and machine against
Right.
man and machine." And they said, yeah, but the little guy in Zimbabwe can't actually afford to buy these bikes. And it's like, well, what are you talking about? The little guy in Zimbabwe can't afford to actually buy a tyre because the tyres are so friggin' expensive. And I'd said to the guy from the UCI, if you really want to actually make it man and machine against man and machine, then and you want them to comply with all your regulations, you should give them hobby horses, because then you just run along on it and don't put any grease in there, because if you put grease in there, that's technology.
And what else have you invented, mate?
So I came up with a concept of making a caster that goes in a straight line. I'm sure you actually know the dramas of pushing a shopping trolley or anything across a car park. So I found that there was actually a maths problem with how the geometry worked on a caster. And just recently I've put that onto the concept. So I've changed everything that I've worked on and put the idea of adjusting the trail into a power wheelchair from Germany.
Right.
So we've done that, and that's actually it was actually in Brisbane, and now it's actually being tested in Perth.
Yep.
And it's taken a hell of a long time to actually go from point A to point B, but it's actually done.
Great. Well,
it works really well.
Hopefully it's going to get out there, because that's one thing that really annoys me when going shopping, especially when the shopping trolley's full.
Yeah.
You're just seeing these people, wrestling with this shopping trolley. What else can you tell us, man? Give us one more thing before we move on.
It was really funny. I was actually doing the same thing, just testing it out on a shopping trolley, and had all these people telling me how steering should work. And I saw this lady walking past, and it's like, how many blokes do you know that really go out there and seriously shop, right? What ended up happening is there's a woman walking past the car park, and I've got these casters that I'm doing some initial testing on. And what happens is I go to the woman, excuse me, can you actually push me inside this trolley up to the back of your car? And she looks at me really strange. And at the time I was about 90 kilos, right? So I jump into this shopping trolley, and she pushes me straight to the back of the car, and she goes, shit, I can actually push you straight in.
Yeah,
So
right.
the surprise on her face was just priceless.
Mate, that is one of the things. I mean, people generally go shopping once a week. They do, or maybe once every 2 weeks. They do a big shop. It is sometimes scary if you cannot handle that shopping. You know, and you know how many cars have been dented because of that.
Oh,
Right?
look,
So hopefully, you know, we're going to solve that when your technology comes out. Mate, give us something else that you've invented.
okay, so that was one thing. We've looked at some materials to strengthen up carbon fibre. So I've done
Right.
some testing just recently in Taiwan. So we took some composite and we laminated it with some special resins, which I can't disclose.
Right. Fair
But
enough.
we could hit them with a sledgehammer, and the carbon fibre wasn't cracking. So it was brilliant, because what it means is that you can make lighter structures and you can make them a lot stronger, and that has implications for the building industry as well, because
Right.
it means that we can make pultrusion. So that pultrusion's like some fibre. You know how you get the reinforced steel that goes into concrete?
Yes.
Okay, and
Yeah,
the
the Rio.
joke is you get what you call concrete cancer, right?
Yes.
So the concrete actually starts to break up because the bars rust, or you get some cracking in the slabs, and you get all these dramas that form out of it. We're using these materials with new fibres and new resin systems. You've got higher strength than the steel, but the issues have always been things like the temperature of the material. Steel can go to higher temperature before it actually yields.
Right.
So you've got all these compromises, but using this type of technology, you've got something that's actually a lot lighter. So the concrete can withstand a lot more loads, and it doesn't have to support its own weight. So the more weight you've got, the harder it is to support itself.
Yeah.
You know? So the engineers have to do a lot of work, but before you can actually take it to that sort of level, there's a lot of engineering that has to be done and a lot of testing.
And
And the
when do
good
you
part,
think this kind of technology will be out?
well, they're already playing with pultrusion, but most of the pultrusion that's currently out there can be crushed very easily, and the temperature that it can get to is not very high.
Right.
So they're already working with it. But what we're actually working with will probably be 2-3 years down the track before it's actually goes anywhere. Having said all of that, the company that's actually doing the work, I helped set up the clean rooms in Taiwan on this trip, in fact.
Yeah.
So there hasn't been a composite company set up as clean as this one. I mean, it's pretty amazing. You walk past the sensors, you sweep your hand past it, and the doors automatically open, and then you get blown off with not compressed air, just airflow, and then you walk into the room and you start mixing chemicals. So
Yeah, right. Well, we'll get to your trip to Taiwan a little bit later, because you actually spent about 7-8 months there, I think, recently. Mate, what do you? Let's get to your thoughts on some of the things going on around the world at the moment. I'd like to get your thoughts on Elon Musk and Tesla. What are your thoughts on that as an inventor yourself?
yeah, I think I actually like what Elon's actually been doing. My cousin actually does Lamborghinis, Ferraris, all sorts of weird things, and he's constantly telling me that I should actually have a look and modify one of the Teslas with some of the technology that we're working on, which is scavenging of electricity. So it's a different way of looking at how to store electricity in supercapacitors.
Right.
And supercapacitors have been a fascination of mine. What you don't know is I went back to night school to do electronics, just because it interested me, not for any other reason. And supercaps are getting better and better and better. I mean, they still haven't got the density of a battery, but the fact that Musk has actually bought out one of the large supercapacitor companies tells you that he's definitely on the right track and understands the market and where it's actually going. I mean, there's a lot of problems that actually need to be resolved worldwide, and I think we just have to be honest with ourselves and open to some of the issues and that are occurring. I mean, one of the problems has been the density of electric motors and the density of the batteries. And people don't realise that some of the batteries have these things called dendrites. They're like little tentacles, that form, and they can puncture the battery, and then the battery can catch fire. So there's risks from some of the tech, and it hasn't.
That's happened with mobile phones, hasn't it?
Yeah, well, I mean, it's happened with phones. It's happened in the bicycle industry as well. I mean, we've actually seen a lot of battery technology where it's been rushed through, and people buy the cheapest product that they can. I don't know how that goes with carbon footprints when everyone keeps rabbiting on. But anyway, they buy these products and they failed. I mean, even to the point where I had one of my customers running through a garage as his cheap imported battery was catching fire, and it's like, and all the cells are exploding whilst he's trying to run away from the garage. It's like, really? And we just let that sort of stuff come into the country. It's like, you just got to shake your head and say, you know what, let's just deal. All I can do is, as a Jaffo, just deal with one problem at a time.
Yeah. Now, you spoke about carbon and carbon emission. What are your thoughts on that? Because I know you have some pretty strong thoughts on what's going on with carbon emissions and so on.
I'm pretty passionate about sort of trying to look after the environment, and I think a lot of people actually, they keep blaming instead of actually telling me. I hear lots of blame, like everyone blames CO2. You know, they blame this, they blame that. You know, you get people that are educated saying that they're blaming the past. The people that actually,
if you think about your father and my grandfather, out in the back, just burn. No, what I do with this cardboard, burn and all what. What about this plastic? Burn the plastic. It burns the I swear that right up above my grandfather's house, there was a hole in the ozone layer, right above his house. And like my father was, a lot of the old ethnics were, right? So
yeah,
that's why people are blaming the oldies, right?
Well, they're blaming them, but then when you actually sit down and really, I mean, look, when I was at school, I was always told you've got to have a study, right?
Yeah.
And I listen to these technical experts, and sometimes I shake my head. So I'm a bit of a jerk when it comes to this sort of stuff. I measure things. Mm-hmm. I like measuring things. Mm-hmm. I mean, I've got thermocouples. I've got an infrared camera, so I can see stuff.
Yeah.
And everyone blames CO2, so I thought I'd do an experiment just for myself. I don't need to do it for anyone else. So I filled up a bottle with CO2, 100%. Mm-hmm. You're a food chemist. You understand how to actually do stuff. Yeah. You get some bicarb soda, you get some vinegar, you put it in a jug because you know how to make CO2. Because everyone, if they don't actually know it, they should know it. When they make their sourdough bread, what are they producing? CO2. Yes. So let's stop eating sourdough. I don't think so. Mm. Anyway, so I make my CO2. I pour it into my bottle, make sure it's actually 100% full, light a match, which is what you do at school. You stick it inside. It went out, not a problem, right? Yeah. You fill the other one with 100% oxygen because you can crack water. You can get 100% oxygen. So you put that in the other bottle and you actually do a test as what the temperature difference is between it. You fill another one with black tar because, that's what the roads are made of. So you may as well fill it up with black tar. 40-degree day, stick it outside, stick a thermocouple inside of it. And this is a bit of a surprise. Something that they don't tell us about. I got 4-degree difference in my 100% CO2. I got bugger all difference in my oxygen. It was just a little bit higher than ambient. It was nearly the same as the CO2, surprisingly enough. Then you go into the black tar and you've got 100 degrees. So, Now let me think. Who would think that black car you bought was hot?
Yeah.
I think just every single person on earth just needs to rethink it. And I was really pleasantly surprised to see that Sydney in the urban areas, has actually started saying yes to white roofs and banning dark roofs, which was really cool.
So that's one little thing that people can do to help the environment. Changing, buy a white car, not a black one.
Yeah,
Manufacture your house. If you're going to build your house, have a white roof rather than a black roof.
yeah, and what surprises me is if you go into the studies, there's actually a few studies that you can actually see on the net. And the surprising part, which blows me away, is they'll say things like, "Oh yeah, but it doesn't actually make a lot of difference because of the insulation." It's like, no, it doesn't make a lot of difference to the inside of the building because of the insulation, but it does actually make a big difference to the amount of heat load that actually overall is produced. So the heat is actually trapped in the tiles and then it's released at night. A good absorber is a good emitter, right? So it'll absorb the energy during the day and it'll release it in the evening. But we keep blaming poor old CO2. I mean, a minor gas in the atmosphere does my head in. Absolutely does my head in. It's like, is it more plausible that 4 degrees is going to do a difference to the temperature, or 100 degrees that gets soaked into the earth via the roads, via the roofs, via the colour of the bricks, via the so you've got all this urban stuff that's actually going on.
Now, one thing that I remember having a chat to you about, which leads to my next question. What problems were solved by tragic circumstances that occurred in the world?
Oh, look, I think if you go through history and have a look at all of the wars that have actually happened, everything from the timing systems for machine guns. I mean, when they first started flying aeroplanes, they were shooting the propellers off because the machine guns weren't synchronized. Right. So they learned about synchronization. You actually shoot the bullets between the propeller, not at the propeller. Yeah. So synchronizing was one of them. Explosion forming, forging, butting, forging and butting was really advanced through technology through war.
So, so firstly, just briefly tell us what is forging for the people who don't
forging,
understand.
When you heat up a block of steel or a block of aluminium or copper or a material, and then you slam the thing down with 10 tons, 20 tons, 50 tons, 200 tons, and you form it into a shape.
Right.
But you can also do the same thing. So through explosions, what they found was that you'd have the impression of something actually put up against a wall.
Yep.
And some of it was pretty horrible and graphic. You'd have imprints of people and things that were actually happening, but and at the same time, the same sort of thing, not obviously the disastrous stuff that actually happened, but you could actually use you could put a hole into a product and then actually put a charge inside there and explode it or pressurize it, and then you could make that material flow to the shape of something. So it's a really cool way to actually make products.
And you were telling me about the tragedy of Hiroshima. What did we learn from that?
Yeah, well, I mean, if you have a look at the radiation, and you had your first area. So as you went away from it,
let's just take a step back here. So we're talking about when the bomb dropped onto Hiroshima.
Yeah, so right. You had the first area ring, like everyone was actually killed, and then the next level there was people died from radiation poisoning, and the next level, and as you went out. They found that there was an area where the radiation levels, no one had cancer. And that's how they actually started to work out that they could actually use radiation to actually help people. And it's like, wow, that's really cool. From this horrible tragedy that should never be repeated, if we go back through history, we should grab a brain cell and, not do things like that. But here we were, there was actually something really good that came out of it, to be able to actually help people.
So basically, at a certain distance from ground zero, let's call it, from the point where the bomb dropped. So obviously next to where the bomb dropped, a lot of people got killed. Further out, people died from radiation. But there was a certain point where they found that over time, those people lived to
longer. They actually
longer
had
because that level of radiation wasn't enough to kill them, but was enough to cure things like cancers.
Yeah,
Right.
I mean, and there's little stupid things like people don't know everyone buys bananas. Who knows? Bananas are radioactive as well. Very, very low radioactive, but it's like they've got little tiny amounts of radiation, but that's natural. Right?
Yeah.
People just perceive radiation as being nasty and dirty, and you get all these people that just give you all the reasons why we shouldn't use radioactive materials. But if you actually do the homework properly and do the work properly, there's actually reasons why we should radiate things. I mean, like they do with some of the foods are actually radiated and they last for a long time.
Yeah, well, they use actually titanium dioxide, don't they, in chocolate bars? Explain that to us.
Yeah, that was a funny story. I was in the States, and it was actually a sports conference, or it was in the cycle industry.
Mm-hmm.
And one of the pharmaceutical companies, they had developed these sports bars that you eat. No, I like reading the ingredients. I'm just a bit weird like that. So I'm reading the ingredients.
You know what? You're actually not weird, and more people should read the ingredients because they would learn a lot more about what they're ingesting. But that's another podcast altogether. Sorry for interrupting.
No, that's all right. And I noticed there was titanium dioxide in it. I said to the guy, "How come you guys have got titanium dioxide in there?" He goes, "Oh, well, that one's caramel." I said, "Yeah, so what do you mean?" And he goes, "Well, you've got to make the caramel the right colour so that it's always consistent." They looked at me a little bit strange, first of all, and I said, I really wanted to understand why they put titanium dioxide, because, I mean, this is a material that we use in paint. I mix titanium dioxide to make white paint or to change the colour slightly for the bike industry, and different titanium dioxide from different parts of the world is different levels of white. Mm-hmm. So once you start, you don't want to actually change it. But what do you actually put it in a chocolate bar? And the answer was, well, you've got to actually make the caramel always look the same. Mm-hmm. It's like, really? It's like people are actually that worried about the colour of caramel, and they're putting something in their body that has no nutritional value, just the colour. Yeah.
Mate, while we're talking about food, is margarine one molecule away from plastic? Is that true?
Oh, look, you can look at it that way. I suppose you could actually look at it that way, but if you look at some of the fats in the human body, they're pretty well much all a few steps away or a step away from being plastic. But if you really want to look at it, I mean, you may as well actually say, well, a mushroom is actually closer to a human being than it is to a plant, because genetically, I mean, if you look at the
DNA,
the structure of the mushroom, there's no way it's actually part of the plant sort of species. It really is closer to a human being. It's the closest DNA that you'll get to a human compared to a plant.
Yeah. One thing that was interesting that when I spoke to you about these kind of things was that there were certain problems that were solved accidentally. Like we all know that penicillin came out by an accident. What other things do we have today in this modern world that actually were formed by an accident?
Oh, look, there's a whole heap of them. There's so many of them. It's not funny. I mean, if you look at polymers, for instance, screw up on polymer, and it's like this stuff doesn't go off. It's sticky and it's gummy and it's horrible. And what do we actually do with it? And here's a good example of it, right on my workbench. Post-it note.
The post-it note.
There's the polymer that was a complete mistake. Most people actually don't realise it was a big screw up. They just made tons and tons of
talk us through that. Talk us through how the post-it note came about by an accident.
So what happened is they got the material wrong, the stoichiometry wrong. The stoichiometry is like how much of A do you mix and how much of B do you mix to actually make a material like a solid rubber.
So what were they trying to make? Do you know?
I don't know what they were trying to make, but I believe it was actually a rubber, synthetic rubber, which there's quite a lot of them through the polymer industry, which is what I've been doing actually up in Taiwan. Yeah. But the interesting part is if you put too much of one chemical, you end up with this. And I've made that mistake a lot of times with different chemicals as you're going through. but you actually find it's like, I'd never thought of, sticking it on a bit of paper, but someone goes, oh, look at this. If I put it on a bit of paper, I can stick it on my screen and it stays there forever.
Yeah, right. And then it'll just peel off as well
And it'll
if you
just
apply
peel
enough
off.
force.
Yeah.
And then
So,
you can put it somewhere else and it'll
and
stick
then you
on.
can, yeah,
Yeah,
that
right.
was one of them, which I thought was brilliant. The other one was the pen, where in outer space you need the Americans actually spent an absolute fortune making a pen that would pump ink. So you've got your little heart. I'm sure you've seen it. I won't mention the brand name just in case I get into strife. But you can actually, you could write upside down with this pen, right?
Right.
And the Russians had some technology as well. It was called a pencil. So you get stuff that's used, and you might start in one area and it goes into a completely different area.
Yeah.
There was a company actually trying to do a wheelchair, and the person, the CEO, actually got onto this wheelchair, and the engineer got onto this wheelchair, and you could get on two wheels, and this thing was actually really stable. And guess what? It's actually a completely different product today. So people have actually seen them going around on two wheels with handlebars. I'm sure you know what I'm talking about. I don't want to actually promote one product or another product, because there's a whole bunch of companies that are doing products like that. But there's a lot of things that were actually developed by accident. I remember one article that I was reading on frequency of water.
Mm-hmm.
And so what they were doing was they were pumping the water at certain speeds. And one of the engineers actually noticed that at the high frequency of pumping the water was actually getting hot. So he developed a way to actually make hot water without using heating elements, just by pumping at really high speeds through itself. Yeah. The other one was, there's a man walking past the radar with a chocolate bar in his pocket. Marconi had actually talked about, being able to cook food back in the early days with radio frequency, but the chocolate bar melted as this engineer technician goes past an aircraft nose cone, and every time he went past it, his chocolate bar is melting, and hey, microwave oven, great idea.
Right.
So there's lots of things where things just got developed completely by accident.
Yeah. But I'm very conscious of time. A couple of more things before we wrap it up. Your thoughts on coronavirus and vaccines?
Oh, hard one.
Able to detect the RNA.
I mean, look, it's a real hard one. I mean, I was actually stuck in Taiwan for a long time, and I really have to admire the way that the Taiwanese government actually managed the situation. In Australia, there was a lot of problems with extending visas and things like that. My partner was actually from Taiwan, and we had to drive down all the way to Bunbury, which is one hell of a trip. It's a day out of my life that I won't get back. Yeah. Just to.
Well, Bunbury is about two, because we've got a lot of people listening in from overseas. Bunbury is about 2.5 hour drive south of Perth.
Yeah, so I mean, you've got 2.5 hours down, you've got 2.5 hours back, you're waiting for the doctor, you go through all the tests, you've got to spend $450 to actually get a health check, which is, pretty ridiculous considering you were actually in the country. But anyway, so there's all these issues. I go to Taiwan, I get stuck in Taiwan, they automatically send me a bit of information saying, because the flights have been cancelled, you show them that the flight's been cancelled, and they extend your visa without actually causing you all these problems. And I think we can actually learn a lot from that. They also gave me a SIM card, which was tracked everywhere I went. So if I was exposed to the coronavirus, then I'd be informed, or they'd shut down anything that was actually in there. Now, you'd think that, considering no one recognises poor old Taiwan, they don't recognise it as an independent. So China lays claim to it, which makes it very, very difficult for them to get any assistance. And China didn't alert the world, yet Taiwan monitors China all the time, and they automatically alerted the world as soon as they actually detected the virus. And no one else actually went into shutdown. Now, if we had all gone into shutdown and said, you know what, we're going to just close all the borders for a month, right? Across Australia, across the world, whatever. If everyone had actually done that, I know that it's difficult logistically, but if they had, we would have been in a better position. Hindsight.
Have we learned anything from the development of these vaccines? Do you think that the technology used for them will help us?
Look, I think
with vaccines in the future for other things like cancers, to help prevent cancers.
I think that's actually a valid point. I mean, they had already done studies with cold viruses actually blowing up cancers and blowing up cancer cells where you actually inject it, and because of the rapid rate of sort of the tumours expanding. I'm not medical, so I can't really talk too much of it, but about it, I'm just going off what I remember reading. You know, the tumour cells were actually just dying because they were actually being exploded by the virus.
Yeah.
And they've actually seen the same sort of thing with the coronavirus. So I saw some information about that as well. So it's interesting that something that's actually so deadly could also be a saviour for a lot of people as well.
Right.
As far as the vaccines are concerned, I think everyone needs to be open and honest about, you know, if a vaccine is actually not working, it needs to be pulled quickly. And I honestly do believe that it should be, people should actually have the freedom of choice. Otherwise, we're actually living in a dictatorship. And I find that a bit hard. I mean, we've always been free, and I understand that there's a lot of problems for elderly and young people and
immunosuppressed.
But have we got to the state where we have to dictate to everyone? I mean, I went into a food, I won't mention their name. We'll just say a restaurant, a very, very simple restaurant. And I was told that I couldn't use cash. I had to use a credit card to actually pay for the food because, you know, cash was actually not being accepted. And it's like, are you serious? I also have
being Italian is really hard when you get told you can't use cash.
Well, I mean, number one, and does that mean that cash is no longer legal tender? That's my first question.
You know,
right?
so it's actually illegal to say that you can't accept cash, but
that's actually been changed. I found that that's actually been changed. They can actually refuse cash.
Yeah, that's ridiculous.
So
I find that ridiculous.
I find that ridiculous as well. It's really strange, but that wasn't the issue. One of the issues is I'm pretty anal about stuff that I actually do over here, right? So I clean my FBOS machine all the time, right? And I wipe it down, and you find that after people have actually used it, there's just always stuff on there, right? And it's just to do a comparison. So you don't realise just how much junk is on there. And you go into a hardware store and you can see, you know, dirty fingerprints that have been all over things. So you've got over a value. You still have to key in. It's like, really? You're knocking back cash, but you're actually not cleaning your machine.
It doesn't make sense.
It just doesn't make sense.
Aldo, we've got to get going, but I always ask all my guests this one last question. What do you do personally to live a better life?
Live a better life. Okay. In my own brain, I don't go crazy with eating whatever the hell I can. So in other words, don't overindulge.
Yes.
I do my darnest to just not hurt anyone. I think having respect for yourself and others is actually very important. To give yourself your own personal integrity. I need to actually do a little bit of meditation to really just give myself a bit of a break from all of the crap that goes on. It's really easy to get bogged down and depressed with everything that comes in.
Yeah.
And, you know, if you can help someone, just help them. You don't want anything back. I remember going through one of the Tao temples in Taiwan, and I was quite sick at the time, and they looked after me without asking anything or anything to come back, and they didn't want anything back, which I've actually tried to, not have tried, I've actually implemented in my life. So if you can help someone without actually, and it doesn't, it's not sort of impinging on anything that you're doing, why not? It's like, and so many times around the world that I've traveled, I mean, you've traveled a lot, you really rely on the generosity of others sometimes to actually get you through shit. And to the point where, man, I've got to say, I don't think I've met a culture around the world that I couldn't respect. There's always going to be a jerk, and you try and steer clear of those. And there's always going to be people that are nice. And I'd rather work with people that are nice. And I mean, gosh, I hardly knew you years ago, and with the exception of Anthony. And it's like, you're easy to talk to. It's easy to have a bit of a laugh. Without going stupid. It doesn't hurt anyone. You've just got to, be able to laugh at yourself and get on with life, I think.
Aldo, thank you very, very much, mate. It's been an absolute pleasure. I've been wanting to get you on to have a chat for a very long time. I always enjoy chatting with you. I always enjoy the little tidbits that I get from you. Thank you very much, mate. Have a great day, and I'll speak to you very soon.
No worries. Thanks, Joe. Have a good one, man. Cheers.